ओके स्टूडेंट, हम इम्पॉर्टेंट कॉन्सेप्ट लर्न करने जा रहे हैं, आइसोटोप्स एंड आइसोटोन्स इन द केमिस्ट्री। ओके, सो उसके लिए वी हैव टू गेट टू कॉन्सेप्ट्स के लिए, एटॉमिक नंबर और मास नंबर। सो एटॉमिक नंबर क्या है? सो हम एटम का स्ट्रक्चर जानते हैं, राइट? सो एटम हैज़ अ न्यूक्लियस और you have electrons revolving around it. It's going in a circular motion. Whatever there the protons are there in the nucleus of an atom, that number of protons in the nucleus is called atomic number. Uh, so atoms will have same number of electrons, and same number of protons. So you have electron here. If we say 6 electrons are in their outside, so 6 protons will be in the nucleus of an atom. So जितने protons है उतने ही electrons होंगे, और atom is neutral in nature by virtue of having same number of positive and electronic charge. But this electron can be ripped off, ठीक है? So it will get positive charge, or it can gain electron, it will become negatively charged. So this electron numbers are dynamic, but protons are constant in the atoms. So atomic number is defined as number of protons in the nucleus of an atom. That is called atomic number, and that is represented by Z. Z gives the atomic number, and any element is represented like this. Okay, so what is A? A is mass number, Z is the atomic number. Similarly, what is mass number? So it is total number of protons or neutrons in the nucleus of an atom. So whatever the total count of protons and neutrons in the nucleus of an atom gives the mass number. Why not electron? Because electron, of course, it can gain and lose electrons. Atoms can get positively charged, but there is also one important thing we have to remember: the weight of protons and neutrons are quite similar, and they contribute to the mass of an atom. Mass of an atom is contributed by the protons and neutrons. So it is the count of protons and neutrons in the nucleus of an atom is called mass number. And so 14C6. So say for example, we know all carbon. Carbon is at having 12 atomic mass unit in general. So 12C6, where 12 is the what? Mass number. This is A, and Z is 6, that is atomic number. So 6 protons and 6 neutrons together give the mass number of 12. So this is how the mass number is defined. And then we have to remember one important concept: atomic and mass number is always a whole number. So it's never in the fractions. It is always a whole number. Now we learned about atomic number, mass number, and so we will go to the concept of isotopes. So isotopes क्या होते हैं? Atoms of an element. कोई भी atom है कोई element का, they have the same number of protons but differ in their neutron number. So nucleus of an atom will have protons and neutrons. Okay, so any element, if they say carbon, will have 6 protons, and we can have 6 neutrons, that is 12, carbon 12, we know that, and they are abundance in nature, so we normally write C12. Okay, so but sometimes some of the nucleus will have 8 neutrons or 10 neutrons. So for the but in C14, which is a carbon isotopes, will have 8 neutrons in it. Okay, so but they have the same protons number, that is 6 protons, but have 8 neutrons, 6 protons and 8 neutrons. So any atom which have the same number of protons but differing in neutron number are called isotopes. So there are examples here, like we have 12C6 and 14C6. So what is the atomic number? Is 6. This is the 6 atomic number. What is the protons number? Okay, neutrons number in this? Neutrons number is neutrons number will be mass number, that is 12, minus proton number, that is atomic number 6. 14 minus 6, 8. So isotopes have the same number of protons but differ in their neutron number, or they differ in their mass number. We can also define it like that. So uh, this is one example. C12 and C14 are example of isotopes. Then we have a chlorine. We have chlorine 35 and chlorine 37. So chlorine has 17 protons in the nucleus, but they differ in their neutrons in their nucleus, that is in this case 18 and this case 20. So 18 and 20 are different in their neutrons, and they differ in their mass number also. So this is an example of isotopes. Another is uranium, which is uranium 238, uranium 235. So they have the same number of protons, that is 92, but if you look at the mass number, they differ in that. And uranium 235 is the radioactive element which is used in the nuclear energy. Why it is used in nuclear energy, that we'll discuss later. But this is an important concept, that two elements which have the same atomic number but differ in their mass number is called isotopes. So another example you might be knowing, that this is hydrogen. So hydrogen is 1H1, which has no neutron, but another hydrogen has 2H1. Okay, so 2 is nothing but mass number of another hydrogen, which is called deuterium. Then another hydrogen atom comes, which is 3H1, which is called tritium or tritium. So these are all hydrogen has 3 isotopes. Okay, 1H1, 2H1 and 3H1, and they differ in their neutron numbers in the nucleus, or in the mass number in the nucleus. But there is another less important concept, that is isotones. Isotones, if you remember, you can take the n in here, and which has the same number of neutrons, but they differ in their mass number. They may differ in their mass number or proton number. So examples are, say, 14N7. Okay, so 14N7, it has 7 protons, right? This is the atomic number. 14 minus 7, that is mass number minus atomic number, is give you the neutrons number, which is 7. Similarly, in 13C6, we have a 6 protons. How many neutrons it has? 7. So they have the same neutron number, like 7. They have the same neutron number, but they differ in their proton number. So these are the isotones. Another example is phosphorus 31 and sulfur 32. So it has, phosphorus has 15 number of protons, but how many neutrons it has? 16. Similarly, sulfur 32 has 16 number of neutrons. So these are the example of isotones. Okay, so this is the all about isotopes, okay, and isotones, and we learned about mass number and all. So we'll learn more about relative atomic masses in next class, and how we are going to use this atoms for measuring the relative atomic masses, relative molecular masses, you know. So thanks a lot. Please subscribe my channel, and by clicking the bell icon. Thanks for your support.